Welcome together to our 19th Decisively Digital Data and AI User Group Meetup. My name is Alexander Loth, and we have again very exciting contributions for you today. Our agenda starts after the usual introduction and announcements with the session Chart Choice, Many Ways to Visualize Data by Dilyana Bossenz. After that, I'm happy to present the brand new book Decisively Digital, From Creating a Culture to Designing Strategy, which many of our user group members have contributed to. In our third session today, Shubham Agarwal, Frank Schlemmbach, and Sven Sommerfeld will show anomaly detection for warranty cases with an example of the automotive industry. The announcements for today. Our user group has its 5th anniversary. This photo shows one of our very first meetings in 2016 at the then newly established Tableau office in Frankfurt. Guests had a choice between Coke and Diet Coke. Since then, our group has grown steadily. This photo shows our meetup at Deutsche Bahn Silver Tower, also in Frankfurt, in early 2020. Registrations were well above the room capacity of 200 people. Then came the pandemic hit, and we went completely virtual with over 300 attendees per session. Our LinkedIn group has now over 1,400 participants. If you haven't joined yet, just sign up. We will share session recordings and announce upcoming events there. By the way, the next event will take place on September 30. You can also find the link in the chat. And if you have a contribution for a future meetup, just feel free to get in touch with us as well. As usual, you can find slides in our GitHub repository, github.com/data-ai-hub. So, now to our first session, Chart Choice. Dilyana, the stage is yours.
So, can you see it now?
Yes.
Okay, great. So, hello everyone. My name is Dilyana, and I'm so excited to be here today. And I'm from Uzbekistan, and I have been living here in Germany since 2008. And I graduated in business administration with a focus on business intelligence. And today, I'm an enablement manager in business analytics based in Berlin and working for M2. So basically, my profession is to enable people to work with data and get useful insights. And today, I'm going to talk about different ways to graph data. And I would like to start this session with this question: why do we graph data? That sounds like a simple question, right? But there is not a single answer to this question. Just give me some ideas in the chat. What do you think about this? Why do we graph data? The single words, what do you think? What could be the reason for graphing data? To gather insights. We got the first answer. Any other ideas? Why do we graph data? To show summary and trends. Yes, this is it. I also put some ideas to this slide. So we do graph a data to drive actions, to communicate, to answer a question, to learn, to grab attention, create beauty, experiment, to be informed, entertain, inspire, make someone laugh, explain, influence, explore, to see insights, evoke feeling, better understand data, engage audience, and inform. And we graph data for a ton of different reasons, right? And on this list, we have just some of them. And every time we create a graph, we need to understand why we're doing this, because different reasons help us to make different graph choices. And they might change also the sort of feedback we might get, or direct our focus and prioritize our steps by visualizing data. So knowing why we graph data, who we graph it for, can really help us to direct our own work. And me personally, I'm coming from data analytics area. I create graphs usually to inform people, to create common understanding on something, and to help influence some sort of actions. And if we consider that as our goal, then that help us to make decision on how to show data. I create graphs for creating this aha moment of understanding that help my audience to understand something in new light, or have a smarter decision, or to make a better decision. That's mean I typically choose a graph that people are familiar with, and I don't want to explain the graphs. I just want that my audience to understand them immediately and understand what I mean through my graphs. But before we dive deeper, I would like to do a small exercises with you. So just grab your pen and paper, and I explain meanwhile what we need to do. So my brother and me are big fans of cereals, and we have them very often for breakfast. And his favorite one is with chocolate, and I prefer cereal with raspberries. And for me, it is also important that my breakfast is healthy, has not too much sugar, and that it contains enough wholemeal. So me and my brother, we always had this loud discussion about what cereal is healthier. And that is exactly why we have this data here. Here we compare both cereals. We have a very small table. In the first column, we have some ingredients. I just pick some of them, which are most important. For me, it is wholemeal, sugar, nuts, and then we have this category others. And then you see two other columns for percentage rate for chocolate cereal and raspberry cereal. So now just take 2 minutes by thinking about how many possible ways to visualize this data can you come up with. And I also advise you to make a list of graph types and try to sketch some of them and put your answers also to the chat window. So I hope you are ready now, and 2 minutes starting now. For people who are just join us, don't wonder why we are so silent. We just make this small exercises. Just join us if you want. So 2 minutes left. So welcome back. And I'm sure your list has many options. And I also already checked the chat window. We have different suggestions like bar chart, pie chart, etc. So, and you are absolutely right. So we have data which shows this percent of total. And when we have this percent of total, the first idea what people might have this pie chart. And yeah, pie charts are great if you want to show one piece of the whole, especially good if one piece is really big and another is small. And pie charts work also very well with two categories like yes or no, woman or men. And I think the challenge with the pie chart is that they break down pretty quickly as soon as you want to show more details, because we compare across multiple pies and their segments are physically separated in space and they are not aligned to one common baseline. This is challenging to compare both charts here. Also, you mentioned bar charts, and I'm very curious how many types of bars you sketch there or you have there. Do you have group bar charts? So group bar charts look like this. One reason people mention them a lot here, there's a fixed sum of those things, categories aligned to one baseline, and it is really easy to see if the things are big or small and also compare them to each other. One thing we need also keep in mind that anytime we show a group bar chart, just the way we group things will have implication on what people compare and how they look at your data. So for here, the easiest comparison we can make are things that are close to each other. That means I can focus on all ingredients of chocolate cereals or on raspberry cereal. And it is harder though to compare, for example, sugar between different cereals. And another disadvantage I see is the labeling of single bars. Because of space limitation, I put only the first letter, and the first letter is definitely not enough to understand the context. And I need to rotate the labeling vertically to show them better. And I'm not a fan of rotating the labeling vertically. So this is an alternative to this view. Here I sorted bars in another way, and actually this is a strong advantage of bars is sorting. We can sort categories on the x-axis in different ways. And here I can compare ingredients across different cereals easier, and also labeling is easier in comparison with group bar charts. But what if we add some numbers to these charts? It could look overwhelming, right? So let's try to rotate the axis and put the labeling to the y-axis. So now I can see the labeling better and also put some numbers. And the chart won't look overloaded. But I'm still interested in comparing the ingredients from different cereals. So I tried another sorting here, and I think it looks good for me. So the important thing to know about bar charts that we compare the end points of bars, and we can compare bars with each other in a very easy way. We can see small and big bars immediately. So our interpretation with bar chart is much more correct than with the pie charts. And here also a tip from myself, think about how you want to compare categories. What order does make sense? just keep attention on ordering things, as ordering is very powerful by using charts. Think about if there are any natural construct that people can use. And so think about if you can graph according to this. For example, people usually expect to read things from positive to negative, from cold to warm, from disagree to agree, etc., or descending or ascending order, but also alphabetically order can really helpful too. But what did you also try to show this data in a line chart? I didn't see any comments on this one, but I would say a line chart in this particular case works well. I put categories to the x-axis and I can read them all, but we have a few categories. It's only 4, so it is okay. But as soon as we add more categories, we lose space on some software. We lose space, and some software just rotates them automatically, rotate them vertically, for example. And we need to tilt our head to the right or to the left in order to read the text, and we read information much slowly when it presented vertically. So also be aware about other aspects in this case. When we use line charts, we automatically read line charts from left to the right. We move from one point to another. And with line charts, we can see very well the trends upwards and downwards. And this is how we often interpret line charts. The trend is up and the trend is down, which means that we should also think about the order on categories on the x-axis. Line charts have another advantage. So in this particular example, we see here white spaces and here white spaces. And this is great because these white spaces you can use for annotations. You can add some useful information for your audience and explain things on your chart. And annotations on the bar chart can also work, but it makes the bar chart much busier, and it requires some workaround to make sure if people can read these annotations. We have this percent of total in our data set. So another option to visualize this data is by using 100 stacked bar charts. And I think this chart type is a great alternative to the pie charts because we have consistency according to the baseline along the bottom as well along the top of the graph. But also stacked bar chart provide here a holistic view, which is actually missing by grouped or pairwise bar charts. And I can see here that the raspberry cereal has more wholemeal and less sugar in comparison to the chocolate cereals. So alternative to this, we can shift the vertical bar chart to the horizontal one. And now we have 100% to the right and 0% to the left. And I can read the horizontal chart much better than vertical one. It is easier for me to compare the areas of both charts by looking up and down than left to the right. But it absolutely doesn't mean that you feel the same way. I would say in this particular case, both vertical and horizontal work well, but it's not always the case. And I can also add from my own experience that where I visualize data a lot, I find that some people find this super confusing, this chart type, and don't want to use this graph. And other people find it confusing at first, but then spend enough time with it, and then they realize, actually, I can see some really interesting things when I graph this data this way. So the point here is just think about how familiar your audience is with the type of graph you use and what you need to do to explain to them how to read the chart. And diverging bar charts are often used in survey data, and there are a lot of points to know, a lot of options how to represent diverging bar charts. And my absolutely tip for this topic is the blog post, the blog page of Steve Wexler. He has a website, Data Revolution. So definitely check out this link. I just posted in the chat if you are interested in visualizing survey data. So last but not least, I have a slope graph on my list, and slope graph are really good if you want to show some changes in your data. It is actually a line chart that has 2 points, and intuitively we can understand that when the line goes up, that means that we have a positive change, and when the line goes down, we have a negative change, and this up and down direction create these diagonal lines. And when a graph contains diagonal lines, our eyes jump directly to them. So diagonal lines are super attention grabbing. And in this case, that means that we can really see changes. And by slope graph, it is also important to see the right direction. So we run a risk here if we will not be clear with the categories on the x-axis, that our audience can make a wrong conclusion. So that means that the ordering on the x and y axis is super important here. I speak a lot of ordering because for me it is super important point. If your audience sees no logical order on your graph, they would think there is something wrong with your graph. And you as a designer or as a presenter can lose your credibility here. But the graph could be correct, but the choice of the graph is not optimal here. So as a conclusion, at this point, I would say that there are a lot of possibilities to visualize the data, and this is definitely not the whole list, but maybe this chart are most common. So just remember, there's no single way to visualize data. Any data can be graphed in different ways, and you need to be aware of this, as different views of the data actually allow our audience to more or less easily see different things. And with pies, for example, we primarily focus on part of the whole relationship. By standard bars, we focus on the absolute values. By lines, we compare data from one point to another. With the divergent bars, we can focus on comparison. And finally, with the slope graph, we can focus really on the change. And so taking data and make it visual is one way to do this exploratory process, where we look at data one way and we look at another way and another way. So and iterate through these different views, because each different view allow you to more or less see different things. And so by graphing data in different ways, it can also allow you to make different insights and actually see things differently. So this exploratory part of the process, it really means allowing yourself time and being able to iterate pretty quickly, if possible, through these different views. But I am actually curious, which of these graphs you might choose by communicating this data? How would you make this choice? And I would say our choice depends on different aspects. So our question is, how do you choose an effective graph? And I prepared a list of tips, but it is just only tips. It is not a workaround. This is not rules. This is just tips, what I would like to give you as a friend to friend. The first one is sketching. And I want really to emphasize here how valuable sketching is. Sketching helps you to step back from your tool, and it is a great way to iterate different chart types and to do something non-digital. And actually what we do here is we graph data for exploration and understanding. So sketching is a very good way for exploratory process. Also think about your message. What do you want to communicate? I advise you to write 1 or 2 sentences about what you want to communicate, like, your big idea, or it could be a question what you like to answer. So, and be as precise in your formulating as possible. Another question what we need to think about is here, can you find an answer to this question using one of the graphs you sketched? So just look critically at your work, at your graphs and your message, and also keep in mind that for your audience, you want to explain insights of data, you want to explain your message through your charts. You need also to be sure that your graph is going to be working for your audience if you create it in your tools. Sometimes there are cases where I look at the data and I be like, oh, of course, this is going to be a line chart because I have this continued data and I have this measures 100 line chart. And then you plot the line and it looks like spaghetti. And all lines are just crisscrossing. And it's as if I took a handful of uncooked spaghetti and throw it on the ground. So the point is here, just think about what is working by sketching, or you think this could be an effective way to visualize data, will not necessarily work in your tool. Another point you need to think about is, what do you want to enable your audience to do with the data that you are showing? Do you want them to they compared categories, or to see this general trend or any other big idea? So do you want to create an interactive dashboard and put a lot of filters on it, so your audience decides themselves which data they want to explore? Or what kind of device they will use by exploring your chart, by looking at your chart? And if they use a cell phone or it is a laptop, for example, if they use a cell phone, what is usually much smaller than your laptop, so it is harder to use a lot of filters there, or to see all quick infos or annotations. So I would reduce the number of interactions to the minimum. And also, another tip is choose a graph your audience is already familiar with. So bar charts and line charts works always well, and there are most common chart types in business dashboards. But that also doesn't mean that you shouldn't use another chart types. The point is here how you enable people to read these charts. Just think about if you present the chart and you will take through the chart and explain how to read it in person, or you give a dashboard to a colleague, so he should explore your chart on himself. And this is 2 different ways, right? And in every option, you need to think about, how do you make your chart understandable? How do you enable people to read your graph? How do you make people familiar with your work? So you need to think about these legends, context, annotations, and also your presentation skills. And it could be sometimes a very long way to make people familiar with your graphs. I will also advise you to get a feedback on your graph from a friend or colleague. So when you are graphing data and you are not sure whether it's working, show it to someone else. So have them talk you through their thought process, what they pay attention to, what questions they ask, what observation they make. And this can be really useful for figuring out whether the visual you are created is serving its intended purpose. And last but not least, also just take notes of how you are having to talk through the graph and how much time you are spending thinking about how to read the graph versus being able to jump into the data and the insights. yeah, this is the whole list of advisors, but also remember that this effective graph, when it comes to explanatory, you have something specific you want to communicate to your audience. The red graph creates this magical aha moment of understanding when people just understand what is the message, what is the point. And when it comes to create that, there are benefits to using graphs with which our audience is already familiar with. And also be aware that the graph from your exploratory analysis, from sketching maybe, not be the same view that's going to be help you communicate the same insights to your audience. That's mean you have your own aha moment with one chart, but your audience could have their aha moments with another charts. So this is just think about how you communicate, which chart will you use for your audience. And this talk, I want to end up with this picture. This was taken in Pisa, a small but very popular city in Italian, popular because of this leaning tower, and a lot of tourists take a picture with this tower. Many people make some jokes by trying to take a photo as if they were trying to catch or push this tower. And under the right angle, the photos are very well done and everybody can understand this joke. But if you take the photo at a different angle, like this picture, for example, you no longer see the joke. This looks just silly. So I wish you as a designer to designer that you always find the right angle to see and communicate your message properly to your user. And if you want to challenge yourself one more time, feel free to download this data. I just put this link. Put this link to the chart window, so you can download it here. And yeah, feel free to download this data, create different chart types. I will also do this, and I will post my solution via LinkedIn in a couple of days. So also just add me per LinkedIn so you see my result too. But also I have a very short annotations, announcement, sorry. I'm too looking for new team members. We are currently looking for people in this area. And if you are looking for a job, please apply. And maybe you know someone who is looking for a job, then give them this tip. So we are located in Berlin and we have here 2 wonderful big offices, but it doesn't mean that that people have to be in Berlin. We also offer remote work, and it is totally okay if you speak English, but of course German is a definitely plus. And yeah, I just put this link also in the chat window. And yeah, this is my references to this presentation, Storytelling with Data. This is my address to learn how to work with data and visualize charts. And yeah, this is it. If you have any questions, you can ask it now. And Alex, back to you.
Well, thanks a lot. This was an amazing session. It was really very, very cool. Thank you, Dilyana. And yeah, do we have some questions? You can use the chat for questions, but you can also unmute yourself and just speak up as you like. Of course, if you have some questions later, or if you're interested in some jobs at M2, then please feel free to contact Dilyana via LinkedIn.
Thank you so much for having me. I also sent you this presentation so everybody can see the slides. Thank you and have a good afternoon. Bye-bye.
Thank you very much. Bye-bye. And yes, thanks for sharing the slides. We'll put them on the GitHub later then. Now, I would like to introduce you to our new book, Decisively Digital, From Creating Culture to Designing Strategy. The idea for this book came from the numerous sessions in our Meetup series. It is, so to speak, an in-depth reading on digital transformation. And it includes 24 interviews of executives and entrepreneurs, all experts in different fields, like digital culture, artificial intelligence, Internet of Things, blockchain, big data analytics. Many of them you already know as speakers from our Meetup sessions. Among others, Florian Ramseger, who will show his concepts for the digital society. And Elisa Fink, who takes us on her journey and shows how she shaped digital culture in Tableau's early years. And Mike Romer, who recently showed in our Azure-themed meetup what benefits the cloud has on data analytics. You can find these and all 24 interviews in the book Decisively Digital, From Creating a Culture to Designing Strategy, which was just published a few days ago by Wiley and is now available in all bookstores. You can access the website directly by scanning the QR code. And as a perfect transition to our next speaker, he is also featured in the book with an interview, Sven Sommerfeld. Sven discussed the benefits of hyperautomation in his book contribution. This is super cool, and he shared really plenty of insights. In the book, it looks a little bit like this. That's actually the beginning of the chapter, and here you can see some of his insights. As Sven is already in the call, that's actually a good time to say hello, Sven.
Hi, Alex, and thanks for having me in that meeting and letting me speak. And most of all, that I've had the pleasure to do that interview with you and talk about RPA and AI and how the business can be transformed using these two awesome technologies in the years to come. When will the book be available? Maybe you can also answer that quickly.
It's already available as ebook, so you could get it on Amazon for your Kindle application, and also at several other bookstores. The printed version, due to logistics delay, will come a little bit later, maybe the next few weeks, but it's already available for pre-ordering right now. So just follow the link or the QR code, and then you're all set. Well, I'm all ready to hear what's coming next with the anomaly detection for warranty cases, with an example of the automotive industry. So I would say, Sven and team, the stage is yours.
All right. Thanks, Alex. So let me quickly share my screen. With me is Shubham Agarwal. He's our lead data scientist. My name is Sven. As Alex said, I'm the CEO of ATCS. And what I want to show you today, or want to talk to you today, is a project we have done with one of our customers, which is called Anomaly Detection for warranty cases. But maybe first, because I mean, us as ATCS, we are not that well known yet. Let's put it like this. And first, I want to answer the question you might have, which is ATCS who? Who is this? So that's first I want to answer to you. Then I want to give you a quick insight on the use case, which we have prepared. And then Shubham will go into the details and show you actually how we went about it. We are not allowed to show you any concrete numbers. We are not allowed to show you the final result due to NDAs we have signed and IPs which are behind that. But we can give you an insight on the methodology, how we went about, and I hope this will be insightful for you, and that you can also use a similar approach to help your business. First about ATCS. So ATCS, what are we, or who are we? You can see slide 2 now, right? to make sure. I assume that's
yes, very well. Yes.
Okay. So what we are a IT service firm which is focusing on digital transformation and data-driven decision making. That's very generic, but in the end, that's what we are, and that's what our core focus is. What we are doing as ATCS is basically we structure ourselves in 4 services. Enterprise IT, which is the classical IT, I would say, like the old-fashioned IT, and not called old-fashioned, but the classical IT, managed services, custom software development, consulting, and test management, test automation is in that. Then we are in the digital transformation space, or we call it digital, where we basically talk about or implement solutions on new technologies like cloud development, APIfication, API first, cloud first development, cloud native development, serverless development, all these kind of things, and RPA. Then we are in the services of big data and analytics. That's what we are talking about today, which is basically covering everything from use case definition to API definition to data exploration, data engineering, data smartifying, let's put it like this. So putting AI models, machine learning, deep learning models on the data to make more insights out of these data, and then of course to reporting and visualization. And the last service area we are in is the marketing tech and insights, which is basically everything that has to do with digital marketing and omni-channel approaches, but not as a content provider. We are the tech provider behind that, making sure that the processes are automated, that the data is analyzed, that you gather all the data, how your campaigns are performing, and that you know how to change it in the future. As you can see, we are worldwide spread over 10 offices, where we have 7 so-called branch offices, which are close to our customers, and we have 3 development centers in India. All in all, we are roughly 1,000 employees right now, spread over this, with the majority of it in India, and we are partnering with several companies in order to provide value to our customers. Last but not least, and then I'll end the marketing show for ATCS, but typically when are partners working with us? So partners or customers look to us when they are looking for a local IT partner who sits next to them, who can speak the language, who can create solutions on site in their language with them, and then get that delivered via a global team. When they are looking for a very flexible partner, where we are talking more about solutions and less about change requests. So this is something where partners, when they come to us, they want and they see in us and they want to do with us. When they're looking for a fast and agile software development data science partner, when it's really about speed, getting stuff done, trying things out without, again, talking too much about what was written in the original contract. We wanted to have a solution, and we are going to provide you that solution together with you, and that's our approach. That's how we go about it. And of course, for a cost-efficient partner, because given our global setup, we can give you a different price than purely on-site partners or even nearshore partners. Use case I want to talk to you about today is an anomaly or fraud detection, which we have done for one of our customers for warranty cases. So what was their problem? Their problem was that today they already were looking into this and trying to figure out of all the millions of warranty cases which are coming in, which of these are potentially fraudulent, or we call it anomaly. Which of these warranty cases do not match the patterns of all other warranty cases which are coming in. So there's of course some complexity to it, because there are parts involved, there's labor involved, there are work instructions involved. So all these kinds of things you have to put into consideration to find out where the problems are. And what was in place was a rule-based system where they have some rules with thresholds, and this way they could figure out some anomalies which actually were fraud, some were just misunderstanding of the procedures they had to do. So the problem here was that the effort to find these was very, very high. And once you found a potential anomaly, you had to get the whole history of this and put it together into a report to double check if this is correct. So what we came into the picture, and we wanted to find a better way of doing that. And what we did is basically we put in an AI model which not only uses internal data, which also uses external data, and which uses unstructured and structured data to basically find out which of the warranty cases which are coming in are potentially an anomaly. And we want to display that to the customers so that they basically, with 3 clicks, they see, okay, these are within the last week, I got 5,000 potential anomaly cases. Now I want to look at them all at once, and I want to make a decision which cases are really anomalies and not, and how do I go about this. And that's how we built this whole system to provide that data to the customer, executed by an AI model and then visualized on a Power BI dashboard. And this report was then given to the auditors and the warranty inspectors to make sure that they have all the data handy and they can act on that. In general, the value add for this is that we could reduce the manual efforts of roughly 2,000 working hours per year, and we could reduce the cost for that OEM by roughly $1 million per year, because we could identify now wrong warranty cases, which would then be declined, which weren't found before based on the rule-based static system. How we went about this? This is a classical project execution, what you're seeing here now. We went via the requirement analysis, the data acquisition, the data analysis and engineering. And we did also the platform selection on where we put this and how we can set this up to the model development and training and the model deployment. So while there are cloud solutions which could be integrated here, in this case, we were not able to do that because the customer didn't want to do that, because they didn't want to put that data in the cloud. So everything that you will see at a later stage is kind of handmade in Python. Shubham will walk you through it, but in case you're wondering why we haven't used the sophisticated cloud environment here, this was a requirement we had. The main message from this is that in the end, the whole project is a combined effort. So you will have experts from us who are coming into the picture, who know warranty, who know the data, who understand the business. You will have our data scientists who understand the methodology behind, the math behind it. And of course, we need the experts from the customers in this too, to make sure that we understand not only the business in general, but also the business specifically within that customer. And this combination then is the setup for a successful project. And the integration is very tight, so we're really working here in a partnership to make sure that we can deliver the value which is intended to be delivered. So at this stage, I want to hand over to Shubham so that he can, in the next 10 minutes, dive a little bit deeper into how we went about it, what we tried, and how the results have been. Shubham, handing over to you. You're on mute, Shubham.
Hello. Hey. Thanks, Sven, for passing the torch. So from here, maybe I will take it over. So hey, everyone. I am Shubham. I am working as a lead data scientist at ATCS, and have built a lot of machine learning and AI based model for automation vehicles and automotive vehicles, where they need to deal with warranty claims, fraud claims, navigation system, part detection, or vehicle route prediction, many use cases like that. But today we will be discussing about, as Sven recapped earlier, the anomaly and fraud detection, where we will try to detect warranty frauds or warranty anomalies that often arises when a customer is servicing their vehicle and dealer might raise some kind of fraud claims that the OEMs doesn't want to, let's say, refurbish. So I will just quickly share my desktop screen. I hope it's visible to everyone.
Yes.
Okay. So I will not sharing it in a full screen mode, because I have my Python code as well here. So the thing we developed, didn't want it to be a black box. I will definitely not be going through the line by line of the code, but still, if someone has any questions, feel free to interrupt, and I will love to answer that. So, starting from here, just the basic objective of this anomaly detection was to detect the claims. Initially, the claim, they had the rule-based system in place where any kind of claims comes up, if they pass certain kind of rules based on the model of the vehicle, based on the VIN number of the vehicle, based on the VIN numbers of the vehicle, and anything else. Uh, the rule-based system was in place where the machine used to automatically uh, approve the claims if and some in most of the cases 70% of the fraud claims and anomaly claims, more than 70%, in fact 72% here, about 72% of the fraud claims were getting approved. Now the idea was to how to intelligently identify those claims, that okay, they are fraudulent claims and they are not valid claims and they are not to be approved. So here I have some data set that we used. This is an actual data set. I will not definitely not be showing you the whole data set here. And I will not be definitely showing you the whole data set here. I've also hidden some domain names and the column names so that customers IPs in place. But yes, I will just show you the agenda. So first of all, uh, 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 the whole process is divided into 5 steps basically. First step would be the data analysis and the visualization, how we analyze the data and visualize the data. So I will not be covering a lot on this step. This is where feature engineering comes into the picture, and basically it's more on the domain side, where how we manipulated data, how we translated the data from how the original data we received and how we converted into the format that now we wanted to train our machine learning models on. So I will not be going into very deep on that. Now, the next step would be the data resampling part, where how we intelligently did the data resampling, why the data resampling was used, and where should we use this data resampling method. Then the algorithms, machine learning ML-based algorithms of the anomaly and fraud detection. Then some machine learning models that we use to train this data and to predict the results on it. How these models were evaluated, most of us are familiar with the term accuracy in the machine learning space, but again, accuracy is itself is a very large, very broader term. So just accuracy doesn't suffice in predicting if the model is working correctly or not, and how the model will perform in the actual world scenario. So what were the model evaluation techniques that we used at the end, which model we finalized, and what kind of results we were getting. So feel free to interrupt me anywhere, and I will love to answer any queries. So I will first quickly jump on this data analysis and visualization part. So I will just quickly over through the data. So this is the actual Jupyter notebook with actual codes in it, and hope the screen is available to everyone. So basically we had around 30 columns here and 31 columns here, in which these columns were not actual data that we received, but these data was once after doing the feature engineering on it, these columns are converted into these formats. These columns comes in different format where sorry about my dog, she's getting excited a bit today. So yes, these columns were based on the feature engineering step that we employed, and some of them are like how many times a customer visited a dealer, how many times dealer has to do a same kind of repair, how many times dealer charge, what was the amount the dealer charged for that claim, and based on that, after that, there's a last column, which is the class, which you can see here. This column shows, okay, basically what is 0 and what is 1. If something is 0, this means that it is a valid claim. That was a valid claim, and that was a good claim. And if something is 1, this means that okay, this was a fraud claim. So this was something that how we created this data set. Now we will be training our ML models and algorithms to predict future claims on the coming data sets. So this was basically how our data looks like. I'll move on to the next step. So here I will be talking about the data resampling, how we did the intelligent data resampling. In most of the cases, this data resampling part is not being used, not used, but in the cases of fraud detection or anomaly detection, this is something that needs to be deployed or needs to be there to get a good results or good prediction out of it. First, I will go into detail what is exactly what I mean by data resampling and why it is used here. So here you can see, if I share my screen, if you can see here that we had around 5,000 cases where the claims were the valid claims and they were not the fraud claims, and there were only 50 cases where the claims were fraud claims. If I started training my model on this data sets, the model will be heavily biased towards the valid claims, because the amount of data, the volume of data present for the valid claims is very high. So if you can see, around or 99% of the claims were the valid claims, and only 1% of the claims were the fraudulent or the anomalous claims. So definitely we cannot use this data directly towards our model training part or the machine learning, using in the machine learning algorithm part. Otherwise, the results, the output that we would get would be heavily biased towards valid claims, and it will not detect the fraudulent claims with that great of accuracy. So here, when I plot the data on a 2D dimension, here how it looks like. If you can see here, the data looks like the blue data set is the valid claims, and the red points that you are seeing right now is the anomalous or the fraudulent claims. You can see from this visualization that, okay, definitely the volume of the fraudulent claims is very low. You can, from this visualization, however, you can also see that, okay, there's a definite criteria between, okay, which claims are the fraudulent one and which claims are the valid ones. But still, the volume is quite low, and we need to perform some kind of resampling to increase the volume of either the fraudulent one or decrease the volume of the valid claims. So here basically there are two ways of doing the data resampling. There are two more ways, others as well. But right now we'll be discussing today about undersampling and oversampling. In the left side, here you can see this is our original data set. And in undersampling, what we do is generally we remove some of the data of the majority data set, so that both of the data sets becomes of the same size. So let's say this is our 5,000 data set and this is our only 50 data set. So in this case, we will remove around 4950 data to create both the data sets of valid and fraudulent claims of 50 and 50 each. Or the second way of doing that is adding more samples to the minority class, that is the class that we have of the fraudulent claims, so that both the data sets should have around the same size of data. So here we use the oversampling aspect, where we added. So I have explained here as well in the notebook that these are the two ways that in which we can do the undersampling and oversampling. But for here we used the Smarty library for this. It's a Python-based library where it is basically used for oversampling technique, and I will be using going forward this library to generate the more data sets of our undefined class. So after doing that, you can see how our new data sets gets generated. And now you can see that, okay, the blue data sets and the red data sets are in the equal quantity. So if you see the shape of both the data, you can see that, okay, now the fraudulent claims are also in the have 5,000 data points, and the valid claims also have 5,000 data set points after the resampling. Now, after the comparison between these two images and these two data sets, you can see originally the original how the data has changed from the original up to after the resampling part, where we after the using the oversampling technique, we increase the data size to 5,000 for the 50 fraudulent claims. Okay, so moving forward, there are basically two ways of doing fraud detection algorithms or anomaly algorithms. First is so this first I will explain the use case, how our claims come up and how our model should work. So ideally, what happens that there can be two kinds of vehicle, either passenger vehicles and the commercial vehicles that often encounters a breakdown and they have to go to a dealer or a repair shop to repair that vehicle, right? So once that vehicle is repaired and let's say that vehicle is in a warranty period, then then dealer will fire the claim to the OEM. OEM will process that claim based on some kind of rules or some kind of you can say mathematical rules they have, and after that, once that claim is processed, they will pay back the dealers for that. Now we receive this claim processing data, which here our model will be sitting, and our model will get trained on this data set that we are receiving, and it will provide that feedback to the OEMs that okay, this data set that this claim that is filed is whether valid a claim or a fraudulent claim. So basically, there are two ways of doing that. First is the rule-based system, and the second one is obviously the machine learning or the intelligent modeling-based system. The rule-based systems are the legacy system which were in place right now, and now most of the OEMs, at least the bigger OEMs, have started to convert into far more intelligent system where where they are trying to incorporate some kind of intelligent trained machine learning based attribute or some AI based attribute where they can detect what kind of fraudulent claims they are being processed. So it's very similar to the claims. You can relate this to a credit card example that sometime often what happens that when you try to use your card in a way that you are not used to, or let's say you're trying to make some online purchase that from a website that you generally don't visit, then often your transaction gets failed, or you get a call from your credit card company that okay, this transaction is being done by this transaction is being done from your card. Are you who is doing it, or they might block the card. So this is very similar to that. Here you can see the example I've in this notebook that let's say there's a card. There are various ways to decline a card or approve a transaction. So first, the limits, the high rates, etc., and then obviously the stolen card or the fraudulent transaction. So here our model comes into the picture here, where if someone is doing a transaction which is not supposed to be done or which is fraudulent in some sense, then our model needs to perform here and deny that transaction. So this is how a machine learning model will work on. So but the difference between the rule-based and the ML-based model is that rule-based model definitely have a fixed criteria that can be easily overcome. Someone can definitely find out that okay, if someone is not approving the card limit above, let's say $2,000, or they are not only approving the card for this particular jurisdiction or website. So let's say if I'm doing any international transaction, then they are only blocking it, something like that. So, but ML-based system is a bit different. The machine learning model learns from the past data, and this changes over the time. The way more and more data comes into the picture, it adapts itself, the model self learns, and depending on that, the model's prediction keeps on changing and becomes more and more accurate. They definitely have better performance, and they can also combine with the rule-based systems. So I will not go into much detail about why rule-based system and ML-based system. Definitely it makes sense that ML-based systems are far more better performant. Now I will jump towards the machine learning models and the training part. This will be a bit technical. I will be discussing about some high-level algorithms that we used and how those algorithms were scored and which algorithm at the end performed best and why. Oh, first of all, okay, so first of all, this whenever data comes up, we just try to identify first of all if is there a particular, let's say, a mathematical criteria or a rule from which we can detect that okay, the transaction is fraudulent or not. Here I used basically just a simple mathematical formula that okay, if this column is less than -3 and greater than -3 and less than -5, then mark that transaction as fraudulent. And you can see that after this, it was with this rule, 22 out of 50 fraud cases, 22 fraud cases were able to get detected. So remember, this was done on the original data set, not on the resample data set. So, but again, this is less than 50% accuracy, and definitely this doesn't work great. So now we will be shifting towards machine learning models, where we use some different kind of models, and the models that we used here were basically four models. First one is the logistic regression, neural network, decision tree, and the random forest. So logistic regression is, you can say, it's a bible of any data scientist. Any kind of problem statement, a data scientist generally uses this models first, and often in many cases this model performs quite good. So this logistic regression based on a sigmoid function, where it draws a graph and try to classify the cases between 0 and 1. The cases above this graph can be a fraudulent cases, and the cases below this graph can be the non-fraudulent cases. And the second one is the neural network. This is a deep learning model that we used, and it trains based on the layers, and we define different kind of layers and neurons to establish a connection. And after that, we trained the model on it, and the accuracy were calculated. The decision tree is a simple yes no based algorithm, where machine inputs the data sets, and by taking the data sets, it tries to classify the data whether it's fraud or it's not fraud, based on simple yes no, by changing the parameters and by changing the data that it's receiving with time. And random forest is basically you can say, a lot of decision trees together. They are used, and out of these lot of decision trees are trained on different parameters, and out of that, either all the decision trees or all the outputs of these are taken, or any one of this is backed. So we use basically three kind of models here, and once these models were trained, we try to calculate the accuracy of those models. And once I will just jump to the accuracy calculation part, how we did the performance evaluation. For the performance evaluation, we just didn't use any kind of accuracy matrix. We use confusion matrix. Confusion matrix is basically true, where it calculates the results between true positive, false negative, and true negative. If a result is basically a true positive result, true positive result is basically that, okay, the claim was valid and the model also predicted valid. False positive is that, okay, the claim was not valid. Claim was a fraudulent claim, but the model predicted it as a valid claim. For false negative is when the claim was valid, but the model predicted is as for fraudulent. And the true negative is when the both model and model and the actual data said that, okay, the claim was fraudulent claim. So this is how the confusion matrix work. And here, what we wanted to do basically was to increase the true negatives as much as we can, so that we can detect the higher amount of fraudulent claims, and decrease these false negative ratios as well. False negatives are basically that claims were valid and the model predicted is valid. So we will be increasing this and decreasing this criteria here in the model training part. So to get the score out of this confusion matrix, there's an ROC curve defined, from which we get the ROC score. And ROC score is an accuracy score which says that, okay, how much this confusion matrix is showing, how much percentage of accuracy. So if something is showing 94, this means that, okay, confusion matrix is showing 94% of an accuracy for a given set of model. So I will go one by one towards these set of models. This accuracy was predicted for the random forest variable, where we trained our model on the random forest, and the accuracy we predicted was for the random forest. The random forest model showed an accuracy of near around 94%. The logistic regression showed a bit lower accuracy, I think near around 91% or something. Now, once we did that, we we adjusted our algorithms weight. So we trained 3 models here. The first model was logistic. We didn't train the neural network in this notebook right now. The second model was Decision tree, and the third one was the random forest. So random logistic regression shows the lowest accuracy around I think 86% or maybe 91%, somewhere around that. Decision tree showed an accuracy of around 92%, and the logistic regression showed an accuracy of around 94.1%. But still, we were not very happy enough with the performance of the model, and we want to retrain it a bit. So there is a cross-validation technique which trains the model again and again on a sample data set. So we use grid search CV. This grid search CV is basically a cross validation technique that we used here to better on the random forest for the much better performance. And after that, I think we got a score of 97%. But still, we wanted to look that okay, if is there a better chance of performing this much or increasing the accuracy, or this is the best accuracy that we can get. So after that, there's a technique called ensembling technique where we trained multiple models like logistic regression, decision tree for random forest, and everyone has their own set of performance, own set of metrics, own set of accuracy output. So in the ensemble, what ensemble method does is basically they overlap the models on each other. They combine all the 3 machine learning models to generate a bigger one set of model, which uses both the functionality of all these 3 models or any kind of models that we want to incorporate. So they are basically two algorithms in the boosting algorithm and the bagging algorithm and sampling method. They are for the more algorithms, but more majorly boosting and the baggings are used. So here, if I remember correctly, we use the bagging algorithm. And after using the bagging algorithm, we were able to increase the accuracy a bit by 0.2%, 0.02%. And after that, we also tried to use the voting classifier. And after the using of voting classifier, we were used again. The accuracy was increased by 0.017%. So total now the accuracy was near around 0.974%, which was pretty good. We tried further. We furthermore tried different kind of models where we were definitely not able to achieve accuracy greater than that, and definitely 100% accuracy in real world scenario. At least 100% accuracy is not possible. So once we did that, we deployed this model to our to the client's premise, and after that the model really was working quite good. And as Sven highlighted about, they were able to recover around €1 million a year after the deployment from the fraudulent claims or the anomalous claims after the deploying of these models. Yes, so this was it from my side. I will just switch back to my PPT, and if anyone has any remarks or Q&A, they can just feel free to jump up.
So we will, of course, also upload these presentations so that you have them handy afterwards. And we will also put our contact information in there. So also afterwards, if you need some information about this or have some ideas and also just want to have a discussion on the name, maybe you saw something and say, oh my God, I solved this way easier. We would be glad to have a discussion with you to learn and also just get in, a discussion with you guys to see how we can improve. Alex, back to you.
So yes, Sven, Shubham, thank you very much. It was also an amazing presentation. So let's wrap up our meetup for today. Feel free to post any questions and suggestions directly in our LinkedIn group. Also, don't forget to upgrade your digital transformation toolkit with the new Decisively digital book. Thank you for joining today. See you soon at our next meetup. Bye, everyone.
Take care. Bye.
Thank you.
Thank
Bye-bye.
you. Bye-bye.